Okay guys, my name is Jason Munitich. I'm the head of software development here at Adroit Technologies. Some of you may know me, we may have dealt an email, whatever the case is, but I'm usually in the back end, kind of making sure our software does what it's supposed to do. We're obviously very proud of our existing software suite. We're very proud of Adroit 10 and Maps 4. They form our LTS product offering and have created a very stable base for solutions to be designed on currently. Of course, that being said, we are looking to the future. We're looking at exactly what Dave has kind of pointed out right now. We have to evolve, we have to become better. And under that heading, Adroit 11 and Maps 5 will seek to bridge some of those gaps and expand on that technology. Okay. Click the button. Click the button. No? Click that button. How about that button? Cool. All right. Sort of know what I'm doing some of the time, so don't worry about it. Cool. All right, guys. So the headlines obviously are 64-bit architecture. Okay. Adroit maps have been 32-bit software applications for the longest time, but the standard for operating systems migrated to 64-bit a long time ago. This is just the natural progression. We didn't really see the need to migrate without proper planning and proper incentive. Okay. We chose to now for version 11 and Maps 5, ultimately to become the new standard. Health service will be part of this equation. I'll explain how the Adroit Health Service is, and the Edge Gateway. Again, further explanation. Okay, 64-bit architecture. Like I said, it's been around and it is the standard for a long time. It has been the standard for a long time. But what does it really give us? What does 64-bit actually enable us to do and help us with? As an example, and I want to spot around the room how many people spot the mistake right up front, but I'll get there. Okay, as an example, a 32-bit number is a certain size and a 64-bit number is a certain size. That number over there is not a 32-bit integer, that is a 16-bit integer, and that was me coming up with a number while I was tired. So just please forgive me on that one. I do develop our software and I don't do that in our software. Okay, all right. A 32-bit number is around about a 4.2 billion in scale, okay. 64-bit integer, as you can see, is, well, I'm not going to try and read that, okay? I don't know what the hell that number is. It's massive, okay? It gives us enormous capacity over and above what 32-bit does, okay? Ultimately, it gives us access to more resources. That's kind of the key here. In a 32-bit system, you have access to a finite amount of resources. The most obvious of that is memory. 32-bit applications are limited in the scope of memory that they can use. 64-bit applications are, near as makes no difference, unlimited. Okay, it's practically unlimited in the space of what we're doing. We're seeing massive growth in the solutions that are being provided or being done by us, done by our customers, and we need to expand. We need more memory. We need more resources for these systems. This allows us also to expand on certain internal constructs. You know, internal to our own software, we have limitations. There are limits on slot sizes, there are limits on tag naming, for example, and these are things that we can expand upon and ultimately cure a few bugbears. The tag name length is a simple but obvious bugbear that many people have had. They want longer tag names. Okay, we're limited to 32 characters at the moment. In line with bigger and growing systems, it's not enough. We need to expand. A little bit of a niche requirement is the ability for us to natively support 64-bit integers. Okay. It is a niche requirement, like I said, and not many systems are capable of even using 64-bit integers, but it does happen. Okay. Ongoing counters, accumulators, whatever, liters consumed, or various things like that are starting to bridge well beyond the 4.2 billion number that I mentioned, and we need to make provision for that. This new version will do that. Okay, 64-bit application compatibility. Now, the external applications, third-party applications, as well as applications provided by us, are bound by the architecture of our software. If you want to connect to our software, you need to make a 32-bit application to do so. This has plagued third-party guys wanting to do their own applications, their own client applications, but it also hinders us. We provide, for example, the Excel add-in, which is a very well received and very well used tool, but it forces you as users to use 32-bit Office. That is non-standard. Okay, so the bugbear is that people have to uninstall their 64-bit Office, which was the standard, install 32-bit, and then carry on running. The limitations are, it works, okay, it works, but it creates a point of consternation that we can get around, and we can, get with the standard, create more convenience for users going forward. Okay, the health service. Every system out there encounters problems. Okay. The reality is a SCADA system, a control system, etc. There are problems, there are challenges, there are troubleshooting events to handle and deal with. And you ultimately need to analyze systems. You need to go onto the system, have a look what's going on, try and diagnose and find the problems. This is true of any software. It doesn't really matter. Actually, it's true of pretty much every software everywhere, not just control and SCADA. But the reality for us is that this is usually quite a disjointed process. Okay, we've got many utilities, there's many avenues of many data, many points of data that are being provided separately, and you need to look at it and analyze it yourself. So we sought to create a comprehensive environment which does a lot of this analytics for you, gathers and compiles the data in a concise way and presents it to users so that you can, look at one place, get the information you need to get quickly, to retroactively diagnose issues and faults and whatever the case is. But key on that is that it opens the door for us to be proactive and hopefully prevent problems in the future. If you can see that a problem is coming, that's power there, that's a stable system. Okay. So ultimately, the architecture that we're building has to be automated, it has to be in the background. So this system will sit behind the scenes, it will sit there monitoring your system, looking at key metrics, and ultimately, compiling it into a sensible format in the background. Along with that goes the idea of transferring that data. Okay. The data sitting in a repository doesn't really make any sense. We've got to do something with that. Part of the vision, as part of our SLA, our service provision, is to gather that data and ship it off-site to our cloud facilities, to our service facilities, so that we can do proactive analysis on your data for you. It's a subscription-based function, but that also gives an enormous amount of potential comfort and kind of, confidence that your system is going to behave and continue behaving, because we're letting you know of conditions before they happen. Of course, we are well aware that a lot of systems are in isolation, they exist in isolation. We ourselves advocate that SCADA systems are kept separate from the internet, okay, for obvious reasons. I can quote a few problem systems that have come before in other software, not ours necessarily, but other software have been plagued by external attacks and things like that. So we advocate keeping it separate. This system will also provide an avenue of working in an offline capacity. So it's going to provide you with on-site diagnostics and metrics, again, in a concise way, in a dashboard view, if you will, so that you can do your own analytics. And of course, our support engineers can come and help you on site or whatever the case is and look at that information in a concise way and get to the problem quickly. Okay. Like I mentioned, the idea is to provide a different level of service, and ultimately the gold star of solution is to furnish online repositories with this data for further analytics. Okay, that's where the intelligence, that's where the machine learning, et cetera, comes from, which will help to both streamline your process and, of course, potentially head off problems. Okay. We already have a number of diagnostic features in our software. This is anybody who has used it for a fair amount of time. Of course, our support engineers use it all the time. But we provide a lot of avenues already. We provide a lot of classic utilities that a lot of you might have seen. Driver monitor, scanning monitor, ADR debug. These are all tools, separate tools, which provide different pieces of information that help you to diagnose a system. Obviously, the aim is to kind of amalgamate that and make it all one coherent piece of information. In our more recent versions of our software, this is version 10, version 10 and Maps 4, we provide the survey activity monitor. It's kind of genesis on amalgamating this data, and if you go and have a look at it currently as it's installed, it does amalgamate some of that data and represent it to you in the same interface. Okay, it's not necessarily making sense of it. You still have to make sense of it, but it's at least bringing it into one place so that you don't have to open 10 different utilities. Okay. Of course, this is where we're going. We're expanding on this and making this much more comprehensive. Okay, that's the view for those of you who haven't seen it. It's themed in dark theme there, so there's a light version if it doesn't look overly familiar to you guys. All right. Okay, event log. Obviously, applications since the dawn of the Windows environment have been logging information to the system event log, the Windows event log. We do the same, and of course we use this as diagnostics from in a support capacity. We use it all the time. This is going to remain a key piece of information, but of course, or a key source of information rather. But we of course are going to process, analyze, and make sense of the data that's in the event log. Windows also provides a lot of built-in diagnostics. Pretty much every time I sit in front of a system that is quote unquote not behaving, I'll look at Task Manager, I'll look at Performance Monitor, I'll look at the diagnostic counter, see, okay, what is happening? CPU use, memory usage, network analytics, all that sort of thing will come into play in trying to understand what's happening to a system. Because we don't exist in isolation. The system itself, the environment itself, plays a key role in understanding a problem or whatever the case is. We are beholden to the architecture we run on. This is true for any system. Of course, there's some subjective analysis which creeps into the fray. I look at a system, I look at it differently, I analyze it differently, and Dave will analyze it differently. Everybody here will analyze their own systems differently. Okay. We're trying to take out some of the subjectivity in the system by taking known quantities that we've got through literally over 100 years of experience, just in, and I mean this literally, just in our dev team, we've got over 100 years of experience between us. And we're trying to understand and say, cool, how can we present this information that I would just intuitively know? Okay, I intuitively know something's going on. I want to present that to the user so that it takes the subjectivity out of the equation. Okay. That's what the system is supposed to do. That's the end goal, the vision of this health monitoring system. Okay. Here's just a snapshot of some prototype dashboarding. Ultimately, Windows, or Microsoft rather, provides System Center as a foundation for diagnostic tools. So what we've also envisaged is, cool, we can tack into this and become a plug-in to Microsoft's own software suite and provide our diagnostics alongside Microsoft's own, alongside their diagnostics, and give you a familiar view, and ultimately a view that, for example, IT professionals, which however many of you guys are involved in the IT equation, but there's always some kickback and some little bit of loggerheads with IT and whatnot. This makes it much friendlier to everybody concerned. Okay. So this is part of the vision going forward. That brings us to Edge Gateway. Okay, the term edge. Okay, it is misused, it's misinterpreted, it's misunderstood. It just is. Okay, edge in a nutshell is exactly like what that quote says. It's processing data close to source. That is more or less the comprehensive, overly simplified definition of edge. Okay. We have decided to kind of expand upon that, much in line with how people think of it as well. We've decided to expand on that in how and where is the data sent, how is it manipulated, how is it made available to external consumers. Okay, so what is Edge to us? Edge is a focused version of our software. We already have, and some of you are familiar with the idea, we've got a full version of our software, we've got a light version of our software, there's various flavors. Edge will form another one of that toolbox. It'll form another version of the software that is further focused and even more refined, specifically tailored for the purpose. Like I said, the important part of this is that, Edge is, our Edge platform is going to be an IO server. Great, that's all good, with the provision for making that data available to third-party consumers. That part is really important, okay? Because if you take away that latter part of the equation, Adroit Agent Server has always been an Edge server. It processes data close to source. Get data from PLC, manipulate data, and there it is. That's Edge. Okay. So this part is critical in defining Edge as a product. Okay, how is it different? like I said, it's got limited functionality. When I say limited, we're limiting the types of agents that are being exposed. We've got many agents in our toolbox, but in order to facilitate kind of a focused view on the system, we're limiting it to key agents, key agent types. Obviously analogs, digitals, the usual that people are familiar with, but there's a whole list that goes along with that is further focused. Of course, like I said, the idea is that it is coupled with an avenue of outputting the data, making the data available to external consumers. This is where Smart Data Services comes in. I'll explain that in a sec. One key differentiator here is that it doesn't have a UI per se. Okay, it's not like our normal software where you've got a classic UI or I've got a smart UI, maps UI, whatever the case is. This is not how this works. We're not dealing with graphic forms and graphical representation of our environment. It's a focused server. As part of the output, we've defined a number of tailored publishers. Okay, so the idea is we're going to get this data out in various formats, and that starts with a library of providers, chief among which will be OPC UA, Azure IoT Hub. I should have inserted Amazon Web Services there, so forgive me in that, but that's also part of the equation. And MQTT as very specifically easy to use tailored providers. Those are obviously very common outputs. Those are common avenues of usage. We've also allowed added a generic REST API or Web API provider. That opens many, many doors. Okay, anybody who's sort of worked in the cloud space or looked at the cloud space, everything's a REST API, everything's a Web API. It's a web endpoint and that sort of thing. So what this does is it allows us to tailor it on the fly to different providers out in the world by adhering to REST and Web API standards. Okay. This actually already enables us to do prototypes using things like Oculus and a couple of other providers that we're already, piloting solutions with with the aim of proving this concept. I mentioned Smart Data Services, and ultimately Smart Data Services has formed a core of our installed product suite for a long time now. Most people won't necessarily be, obviously aware of it, but it is running in the background and it is doing what it's doing. And it forms a communication platform between our servers, between our software architecture for internal use. Okay. One of the most obvious ways that it works is by facilitating TCP access to a remote agent server. Okay, remote agent servers have always talked over name pipes, and name pipes, for those of you who know without me going down a way long technical rabbit hole, is a slightly antiquated technology which is very difficult to cater for on firewalls, etc., and whatever the case is. So we have made it available we've made a TCP connection available. And we've even proved stable access to agent servers via the internet. Okay. So I can be a client to an agent server via the internet technically, and it can actually function like that. We use it, like I said, between our clients and our servers. We literally from a smart UI server to an agent server. Okay. We rapidly started seeing that there was a lot of potential for this architecture to furnish other requirements. Okay, we said, okay, cool, we've got this data, we've got this communication mechanism, what else can we do with it? And of course, that factored straight into the edge requirement that said, all right, make that data available externally to external providers. And that's exactly where this comes in. Smart Data Services will be the platform to furnish this data out into the rest of the required realms. All right. We created a plugin architecture to do this. We created something that essentially allows us to expand and add modules to the system really quickly and really easily without rewriting all the software. But like I said, the standard plugins we plan on shipping on day one cater for a lot. They really, really do cater for a lot. Okay. As part of that, I mentioned OPC UA, and OPC UA is, while it's not technically an external provider, it is itself its own server, which furnishes other clients. So part of this offering, part of the edge requirement, was for us to provide our own OPC UA server. Okay. OPC UA is a standard, it's a well-known standard, it's adhered to by many software packages, and a lot of other SCADAs in the world pretty much default or they defer entirely to OPC UA as their input for data representation. As a weird convoluted spin-off, it actually allows Adroit Edge to act as a I/O server to other SCADAs. Just wrap your head around that. It's a bit weird, but it's true. Technically speaking, at the moment, you would go to something like Kepware, and you would use Kepware. But Kepware has become a slightly difficult concept now because of them being bought out and used internally by other providers, blah, blah. Whatever, long story short, Kepware is not as easily available. This actually opens up a whole different market. Okay. I did mention that there's no UI per se, or no known UI, and the reality is, yeah, we still need a way for people to configure this system. So we said, all right, let's create a brand new flow-based configuration mechanism to this whole thing. Something that will be intuitive to new users to the system, guys who are not familiar with Adroit, but also something that just works for users who are very well familiar with Adroit. Okay. In concept, when you are designing a system like this, you're starting with a device. I have a physical device. I want to get data off that device and I want to put it somewhere. So we decided, cool, let's make the flow work that way. Define your device, define your points of I/O, and publish those points of I/O to endpoints wherever you need them to be. Let's say in Azure IoT Hub. So that's how the flow is going to work in this very simple, simplified environment. It still allows for quite comprehensive configuration, for the advanced users and guys who want to get more out of the system. But for a user who just wants to get a data point of data quickly into the cloud, this is going to work really fast and really seamlessly. Okay, what else will it do for us? Or ultimately for you, the customer, etc. These days, it's becoming more and more prevalent for people to not want to host their own infrastructure or to limit their hosted infrastructure on site. Okay, so we're getting customers coming to us wanting us to host agent servers. That's all good and well, but how do you get data from site to an agent server in the cloud? That's a very difficult question to answer. Currently, it's not really possible for a lot of avenues. This allows us to do this, okay, because Edge, as a very small, very limited server on site with very little management, will bridge this gap. It will get the data from the devices on site and make it available to the cloud provider, ultimately to us in a hosting capacity, or if you wanted to host your agent server yourself in your own cloud subscription, in your own environment. Key in there, and I made it bold, but security is key over there, okay? Because obviously there's always a question in people's head, like, okay, how do we do this securely? Is my data ever going to be compromised? Is the screen going to go off? So, this is important, okay? Security is important, and what we're doing here conforms to the highest levels of security going forward. This is very important for us, and of course, that's what this is going to do. This also allows for expansion. A lot of you, I did mention, a lot of you guys have got systems that are kind of separated from the internet. They're not online, they're not connected. This allows us to do this. Okay, keep your system secure and safe behind your firewalls, etc. Install a limited edge server, which acts as a go-between, a relay for that, to allow data from existing agent servers to be sent into the cloud securely. It conforms to that idea of an air gap principle in network design. Okay, that server is the server that is ultimately talking to the cloud providers, while your SCADA network is totally secure behind your firewalls, etc. Okay, so there's no direct communication between your agent servers and the internet. Okay, cool. That is key in how this works. Right. Okay, guys, that's me. That's my whole thing. There will be a time for Q&A afterwards. So, thank you.